Hi class, I wanted to do an example of conditional probability from chapter 19. So in this chapter you learn about the formula that the probability of B given that A has already occurred is the probability of A and B divided by the probability of A. And while you can do problems using that formula as shown in the book, there is a faster way that I wanted to show you right now. So in this example in our notes, it's about a pregnancy test that was taken by some women, and 100 women tested positive and were actually pregnant. 30 women tested negative while they were actually pregnant. 50 women tested positive but actually were not pregnant. And 70 women tested negative while not being pregnant. So whenever you have a problem like this, where you have a chart telling you information about some sort of a survey or event that's taken place, what we want to do first is total up our columns and our rows. So for example, adding up 150, we get 150 women who tested positive. Adding up 30 and 70, we get 100 women who tested negative. And adding 150 plus 100 gives us our total of 250 women who took this test. Similarly, we could have added across our rows. 100 plus 30 gives us 130 women who were actually pregnant. 50 plus 70 gives us 120. Those are our women who were not pregnant. And again, 130 plus 120 gives us the total of 250 women in this experiment. So now we're asked to find the following probabilities. In part A, find the probability of randomly selecting a woman from this study who was pregnant given the fact that we know she tested positive. Now, the shortcut to do these types of problems, rather than using this formula above, is simply to start with the given. We're told to look only at those women who tested positive. That's our given information. We know she tested positive. So looking at the column of tested positive restricts our view to only these 150 women. So from these 150 women, how many of them were actually pregnant? 100. Thus, our probability here is 100 out of 150, or 10 out of 15, or 2 out of 3, which is about 67%. Okay, let's go to our second one. Find the probability of randomly selecting a pregnant woman from the study if we're given the fact that she had a negative test result. So again, we only look at the given, the negative test result, those 100 women. So from those 100 women, how many of them were pregnant? 30. So 30 out of 100, or 3/10, or 30%. There's our probability in part B. In part C, find the probability of randomly selecting a woman who is not pregnant, given the fact that we know her test was positive. Again, only looking at the given, the positive test results. From those 150 test results, how many of them were not pregnant? 50. Thus, 1 out of 3, or about 33%, is our probability for part C. And in part D, find the probability of randomly selecting a woman who is not pregnant if she took the test and it was negative. From our negative test that was the given, there are 100 to choose from, and of those 100, 70 were not pregnant. So 7 out of 10, or 70%, is the probability for part D. Notice also that A and C are complementary since they add up to 100% and they are opposite events, and B and D are complementary as well. So this was an alternative way to do a given conditional probability problem by simply only looking at the given condition first, and then from there asking yourself, from that pile or that group of people or products, now what's the probability that my event will occur? So by shrinking your window or your scope, you're able to do these problems a little bit quicker than if you follow the formula that is in the book. So I wanted to give you that, and hopefully that will help you become an expert at conditional probability. Good luck.